Hello and welcome to a new video today. So this episode we are going to differentiate 7 different types of this. So we've got 4 types of differential, types of functions to differentiate. So we've got e to the x, ln x, a to the power of x, x to the power of x. So, and then we got our 3 simple rules: chain rule, product rule, and quotient rule. This is going to take a long time, so bear with me. If I start straight away, and then we'll try and get through it, not as quickly as possible. We don't want to rush things too quickly, and then we can get started. So, let us start with e to the x. Definitely the easiest out of all of these. So, e to the x is a very easy function to differentiate. So, if we have a function e to the x, our differential equation, our first derivative is also e to the x. Our second derivative is also e to the x. It seems like there's no limit at all. So therefore the nth derivative is equal to e to the x. Seems quite simple because it is. This time, what if we have a different function, for example? So if we have e to the 2x, our first derivative will be 2e to the 2x. Our second derivative is going to be 4e to the 2x. So we're timesing each time by 2. Therefore, our nth derivative is going to be 2 to the power of n e to the 2x. Let me see if you can spot a pattern here. So if we have f of x equals e to the power of x squared, for example, our first derivative is going to be 2x e to the x squared. Our second derivative is going to be 4x squared e to the x squared. Do you spot a pattern? Let me do the third derivative for a second. So what we're going to get is, if we differentiate this and then times it by whatever's in front, we will get 8x to the power of, oh sorry, that's a cubed, to the power of 5 e to the x squared. Laws of indices, forgotten there. What we get, our rule for differentiating e to the x, or e to the function x, is that our function, so y is equal to e to the of a function. So dy by dx is equal to that function times e to the power of that function. And then it keeps continuing. So we always differentiate the power, and then we put it in front, and then times it with whatever we need to. That's it. That's e to the x. Right, let's move on to ln x. Now, differentiate ln x is just not hard. One thing to remember though is that when you differentiate ln x, you will get 1 over x. That's it. However, when we use the chain rule, I will show you how you can include different functions of such. So say if we have y is equal to 3 ln x, we will get that dy by dx is equal to 3 over x. So whatever the constant in front is the numerator here. Seems pretty simple, right? However, you can't use 3x ln x because we need the product rule for that one. Okay. Now we're going to move on to a to the power of x. So, if we have y equals a to the power of x, what's dy dx? How can we do that? What we're going to do is that we're going to take lns. We're going to take lns both sides. I hope you know your rules of log and whatnot. So what we're going to get is that ln y is equal to ln a to the power of x. So that ln y is equal to x ln to the power of a. Sorry, not power of a, ln a. Okay. Now what we're going to do is that we are going to use product rule and implicit differentiation, which I'll explain in a much later time. However, all you need to know is that dy by dx is equal to is equal to a to the power of x ln a. That is just something to remember. I will explain x to the power of x in an implicit differentiation episode, because it's a bit too complex for anyone that really doesn't know what they're doing. Okay, so now we get onto the big boy. We get onto the chain rule. So now the chain rule, what it says is that dy by dx is equal to du by dx times, what am I doing? Dy by du times by du by dx. You're probably thinking, okay, what is happening here? So what you'll notice is that we have two individual functions. We had one function of y, and then we've made it into two individual differential equations. And then obviously the du's will cancel out, and then obviously this will create a dy by dx. Why is that? Okay, let's get an example. Let us consider that y is equal to ln sine x, for example. You're probably thinking, what the flip? Why are you treating me like this? This is ridiculous. It's easier than you think, genuinely. What we're going to do first is that we are going to let y equal ln u, where u is equal to sine x. So whatever function is inside the function, whatever's the function inside another function, in this case sine x is inside ln x, we are going to make this a constant, a variable, so just u, for example. We are going to differentiate this, so dy by du is equal to 1 over u. We're going to differentiate this as well. So we're going to say that du by dx, so we're differentiating u with respect to x. As you remember from our first principles episode, that the derivative of sine x is cos x. So now what we're going to do, we are going to use this rule. Let me just rewrite it again. So dy by dx is equal to dy by du times du by dx. That is our chain rule. Now, we have these two counterparts. What we're going to say is that dy by dx is equal to 1 over u times by cos x. So you're probably thinking, okay, what the hell is u? Well, how am I going to sort this out? It's easy. That u is sine x. So therefore, we have cos x over sine x. I guess what that is? This is a trigonometric function. A trigonometric identity. Therefore, cos x over sine x is equal to cot x, or 1 over tan. And then that's it. That is the chain rule. I'll go through one more example, but I hope that's helped so far. I hope you already have a prelude understanding of what cot is and whatnot. Okay, let's go on to a different example. Okay, let us consider, so find the derivative of arctan cos x. Okay. Now, I'm not expecting you at this point to know what the differential equation is. Oh, sorry. Let's find the derivative of e to the power of cos x. We have a pretty good understanding, I think, of what the chain rule is. So dy by dx is equal to dy by du times du by dx. That is our chain rule. So we're going to let y equal to e to the cos x. Okay? So what we're going to get is we're going to let y equal e to the power of u, where u is equal to cos x. Going to differentiate this. So dy by dx is equal to e to the power, dy to the power of du. So dy with respect to du is equal to e to the u. So it hasn't changed. Differentiating u with respect to x is equal to minus sine x. So what we've got two individual functions. Let's put them together. So dy by dx is equal to minus sine x times e to the power of u. And what u is? That's cos x. Therefore, minus sine x, so sorry, dy by dx is equal to minus sine x. Let's make this easier. So minus e to the power of cos x sine x. What this is, there are two different ways of doing this. You could, if you're really clever of noticing this, you could literally just differentiate this function straight away. You could just easily say that minus sine x e to the power of cos x is equal to whatever. But you can use this rule as well if it makes things easier. It's much longer, but it's probably not worth all the hassle doing it over and over and over and over again. Okay, so let's see what we can do. There is one more example I would like to go through. So find the derivative of x plus 6. Sorry. Let's do x squared plus 6 to the power of 8. How are we going to do this one? This one's particularly important because it has a very much higher power. Okay, let's do exactly what we've done before. A function inside another function. So what we're going to do is we're going to let y equal x squared plus 6 to the power of 8. So we're going to say let y equal u to the power of 8, where u is equal to x squared plus 6. We're going to differentiate again. So dy by du is equal to 8u to the power of 7. I hope you already know that from my polynomials episode, or you just know it already. Du by dx is equal to just 2x. 6 is a constant, so that goes to 0. Differentiating x squared brings 2x. When we bring the two together, when we times them both together, so dy by dx equals dy by du times du by dx, which is equal to 2x times 8u to the power of 7. Therefore, 2x times 8x squared plus 6 to the power of 7. Therefore, our function is 16x x squared plus 6 to the power of 7. That is our final answer. I hope that's helping so far. I'll put up a few questions to consolidate your knowledge. So we're going to say that 10x to the power of 4 plus 8 to the power of 4. So we have sine. Let's do 3x squared. Then we have cos sine x. Yeah, why not? Okay, there's just 3 simple chain rule questions. Pause the video and then just do these questions. Okay, so what we have now is a product rule. Now, a product rule is very simple. It's not hard. It's where you have 2 functions that are times together, and then you just differentiate them, considering, you know, whatnot. Okay, so the rule for this, so y is equal to u and v, where u and v are individual functions. So u could be cos x, v can be sin x, or whatever. So dy by dx is equal to u dv by dx plus v du by dx. This is our product rule. Okay, so let me just break it down slowly for you. Our derivative is equal to, we keep our function for u and we differentiate our function for v. It is exactly the same the other way around, with keeping the v and then differentiating u. Okay, so let's do a couple examples. So let's say we have y is equal to 3x squared ln x. Okay, so what we're going to do, we're going to let u equal 3x squared, v is equal to ln x. When we differentiate that, we will get 1 over x, and when we differentiate u, we will get 6x. That's what we'll get. Now, very easy. Using the formula, we will get that dy by dx is equal to u, so 3x squared, times by the derivative of v times 1 over x, plus our other pairing, so we have 6x times ln x. Okay, this is what we'll get. Therefore, when we put it all together, those will cancel. So what we will get is 3x plus 6x ln x. But if we, to simplify it further, we can say that 3x is equal to 1 plus 2 ln x. That is our final answer. If you simplify it simply, they might accept that, but It's much better just to simplify all the way. I hope this is helping so far. I really do. Okay, let's consider a more complex function. So let's say that you have 2 cos x sine x, okay? So what we're going to do with this, sorry, y is equal to this. So we're going to say that u is equal to 2 cos x, v is equal to sine x. So when we differentiate this, not by first principles, you just do it. That's equal to cos x. And this is equal to, it's a u, not a v. That will equal to minus 2 sine x. Pretty simple. So we're going to put this all together with this formula. So we're going to say that dy by dx is equal to our u times our v prime. So we're going to say that 2 cos x times cos x minus, because we have a minus on one of the pairings, 2 sine x times sine x. So what we will get is that we have 2 cos squared x minus 2 sine squared x. Now, what this is a double angle formula. So what we can say is that 2, if we factor out the 2, so we have cos squared x minus sine squared x. What this is cos 2x. Therefore, what we will get is 2 cos 2x. That is our final answer. I hope this is really helping. I really do. And then that's it. There's not really much else to go on, to be honest. So I'll put some questions up. So if you differentiate e to the 2x times sine 3x, oh yeah, sorry, I completely forgot to mention another really important. Oh no, you can just, yeah, that's fine. That's no worry. Cos 2x cos 2x sine 2x question. So ln x times, let's do, trying to think now. Let's mix up a little. So we're going to say that 5x squared plus 4 to the power of 3 times ln x. Okay, there we go. So a little hint for the third one. If you, whilst you are differentiating your u function, use chain rule. You can mix up a little bit. That's all right. So we're going to go on to our last one. We're going to talk about the quotient rule. So, quotient rule is a simple formula for it. So, if y is equal to a function of u, a function of u divided by a function of v, then there's an individual formula for this. dy by dx is equal to v du by dx minus u dv by dx all over v squared. That is our formula. So we'll just go through one example because it takes too long to do for one question. It's ridiculous. So if we have okay, so let's prove that the derivative of tan x is equal, tan x is sec squared x, or secant. So, y is equal to tan x. We can say that this is equal to sine x over cos x. Therefore, we have a quotient here. So, u is equal to sine x, v is equal to cos x. When we differentiate both of these functions, we will get that derivative of sine x is cos x, and the derivative of cos x is equal to minus sine x, okay? That's what we'll get at the moment. Now, substituting this in all our formulae, what we will get is that dy by dx is equal to v, which is cos x, times by our other pairing, which is also cos x, minus our other functions, which is sine x times minus sine x. So we've got sine x minus sine x, times sine x, all divided by cos squared x, because our bottom term is v squared. Substitute it in, you'll get cos squared x. So what we will get, if we simplify, is that we get cos squared x plus sine squared x equals over cos squared x. Now, you should recognize what cos squared x plus sine squared x is. It's 1, and that's it. So we get 1 over cos squared x. And the identity for sec x is 1 over cos x. Therefore, so sec x equals 1 over cos x. And if we square both sides, we'll get sec squared x is equal to 1 over cos squared x. Therefore, this will equal sec squared x. I hope that is really clear things up for you. Let's put some more questions down for you all. So we're going to say that e to the 4x divided by sine x. I'm going to say ln x over x, and we're going to say trying to think now. Find the equation of tangent of y equals cos x over 2x. That's what we're going to do. So pause that video and then just do those 3 questions. So I thank you for watching. I hope this has really helped. If you have any questions, please message me. And also go onto my Twitter as well. That's important. I know how to use Twitter, which is delporto_8. I'll link it in the description. If you have any questions within all the maths episodes and series that I've done, please DM me, and I hope I can solve it for you. I've finished the A-level course about nearly 2 weeks ago. Very glad that I have done. I hope you've enjoyed this episode. I have not personally. But thank you for watching regardless. I hope this really helps. Subscribe, please like. See you guys later. Have a good day. Cheers. Bye-bye.